Okay, so today we have the definite integral from 0 to 1 of e to the x all over 1 plus e to the 2x. Okay, and of course with respect to x. Now the first thing is that, well, e to the 2x, this is just e to the x all squared. Now why would I do that? Well, it makes it more easier to see that e to the x is common in the numerator and the denominator. And what does that mean? Well, that hints that I'm gonna have to sub in u for e to the x. Okay, just a hint. So let's do that. Well, let's say let u equal e to the x, and then we say then du is just gonna be e to the x dx. Okay, taking the derivative of both sides. Now, to solve for dx, we can divide both sides by e to the x, so we get that dx is just 1 over e to the x du. Okay? Now let's do our substitution. So this is going to be equal to the integral. Now before I put in my boundaries or my limits, whatever, this is gonna be in terms of u now, so let's not forget that this is still x equals 0 and x equals 1. Okay, so this on the numerator, I'm gonna keep it the same, but you could sub it in. I'm gonna show you why in just a second. Okay, now e to the 2x, we said that this is e to the x all squared. E to the x is just u. This is just going to be u squared. And finally, our dx, we said that's 1 over e to the x du, and you can already see why I didn't sub in u for e to the x. Well, you could, but then you would have to put in 1 over u as well here, so that these can cancel. Okay, so this, well, let me just rewrite this so you're not confused. This would have been u all over 1 plus u squared multiplied by 1 over u du, and then these cancel. But all in all, we get the same thing. Okay, so canceling these two, this is now going to be from x equals 0 to x equals 1. This is going to be 1 over 1 plus u squared du. Okay, now let's stop and let's look at this for a second. I've never seen this integral in my life. That's probably what you're thinking, but I'm here to help. So if we think about the arctangent of u, what is that equal to? I have no idea, but if we take the derivative with respect to u of the arctangent of u, we will get 1 over 1 plus u squared, and then multiplied by the derivative of the angle, so du. But that looks a lot like what we have here, and it is, because since I took the derivative of this and it gave me this, that means, well, I can take the integral of this and it's going to give me this. So all in all, this is just going to be equal to the arctangent, our variable is u, and this is defined from 0 to 1. Well, actually, x equals 0, x equals 1. Now we can sub in our u value, which is e to the x, so we get arctangent of e to the x, and now we don't have to say x equals, so we can just say from 0 to 1. This is going to be equal to the arctangent of e to the 1 minus the arctangent of e to the 0. Okay, let's think about this. This is just going to be e, this is just going to be 1. So we have the arctangent of e minus, what's the arctangent of 1? I have no idea, but since we have Google, this is going to be pi over 4. And you could put these together. I have no idea what the arctangent of e is. I'm pretty sure they do not want you to write that out as decimals or whatever, but we could multiply the top and bottom by 4 here, and we get 4 arctangent of e minus pi all over 4, and these two are your final answers. Okay, arctangent of e minus pi over 4, or this whole thing, and we are done.